Welcome to a new video by Wiskunne English. In this video we're going to talk about mathematical induction. We're going to make 3 exercises and we're going to prove that the left side is equal to the right side with mathematical induction. First exercise. I grows from 1 to n. That must be equal to 1 divided by 2n multiplied with n plus 1. So how does mathematical induction work? We start with n equals 1 and we're going to prove that the left side is equal to the right side if n equals 1. So n equals 1. So we just fill in on the left side we get 1 because I goes from 1 to 1. On the right side we get 1 divided by 2 multiplied with 1 multiplied with 2. So we have 1 is equal to 1. After n is equal to 1 follows the induction hypothesis. So we say that it's true for n equal to a variable, for instance k. So we say it's true for n equal to k. So we have I from 1 to k. I is equal to 1 divided by 2k multiplied with k plus 1. So we say that it's true for n is equal to k. Now we're going to prove that it's equal for n equal to k plus 1. And then if it's correct for n equal to k plus 1, then we have proved that the left side is equal to the right side in general. So now we have n is equal to k plus 1. So we need to prove that I goes from 1 to k plus 1. I is equal to 1 divided by 2 k plus 1 multiplied with k plus 2. Now, I'm going to work with the left side. So, you see, you can write this as I goes from 1 to k, I plus k plus 1. So I can write this as the left side as I goes from 1 to k, I plus k plus 1. Now, I know that this is equal to that. So I'm going to use it. I'm going to substitute this by that. So I have 1 divided by 2k, k plus 1 plus k plus 1. And now I can factorize, so I can put k plus 1 in front. So I have k plus 1. Here remains 1 divided by 2k. And here everything disappears, so plus 1. Now, what can we do? We can put 1 divided by 2 in front of the brackets. So, I divide by 1 divided by 2, so it becomes 2. And you see that this is equal to that, so we have proved in general that the left side is equal to the right side. Next exercise. Two to the power of n is larger or equal than 1 plus n. So, same first step as the first exercise. N equals 1. So we have 2 is larger than 2. So that's correct. Then next, n is equal to k. So we have 2 to the power of k is larger or equal than 1 plus k. And the last step is this. We say that this is true. I'm going to use that for n is equal to k plus 1. So we have n is equal to k plus 1. Then we have 2 to the power of k plus 1 must be larger or equal than 1 plus k plus 1. Now, I'm going to work with the left side. So I can say that 2k plus 1 is equal to 2 multiplied with 2 to the power of k. And then I can say 2 to the power of k is larger than or equal than 1 plus k. So I can say that this is larger than or equal to 2 multiplied with 1 plus k. So we have that, we can write this as 2k plus 1 is larger than or equal to 2 plus 2k. And that is larger than 2 plus k, because k is a positive number. So 2 plus 2k is larger than or equal to 2 plus k. So we see that we have proven in general that the left side is larger or equal to the right side. Last exercise. We have k from 1 to n. 1 divided by k multiplied with k plus 1 is equal to n divided by n plus 1. So first, let's say n is 1. So we have k from 1 to 1, so it's just one number. It's 1 divided by 2 is equal to 1 divided by 2. So that's correct. Then we say it holds for, let's not take n equal to k because we already have a k in the equation here. So let's say, for instance, L, n equals L. So this is correct. K from 1 to L, 1 divided by k multiplied with k plus 1 is equal to L divided by L plus 1. Now we need to prove it for n equals L plus 1. So here we have k from 1 to L plus 1. L plus 1 divided by L plus 2. So we're going to work with the left side. So left side, we can write this as k from 1 to L. K multiplied with k plus 1 plus, then we fill in L plus 1, so we get 1 divided by L plus 1 multiplied with L plus 2. So k from 1 to L plus 1 is k from 1 to L, and then we filled in L plus 1. Now again, I can substitute this with this, so I have left side, so L is for left side, L divided by L plus 1 plus 1 divided by L plus 1 multiplied with L plus 2. So now I want the same denominator, so I need to multiply here with L plus 2 and the numerator also with L plus 2. So I have L multiplied with L plus 2 divided by L plus 1 multiplied with L plus 2 plus 1. Okay? Now, I have a quadratic equation, so we have L to the power of 2 plus 2L plus 1 divided by L plus 1 multiplied with L plus 2. This is L plus 1 to the power of 2. So this we can write as L plus 1 to the power of 2. We can remove to the power of 2, it becomes to the power of 1, and we remove this. So we see we have L plus 1 divided by L plus 2, and here it also says L plus 1 divided by L plus 2. So we have proven that the left side is equal to the right side. This was the video about mathematical induction. I hope you enjoyed the video. Please drop a like and subscribe to the channel.